Okay, looks like we're live.
Awesome.
All right, let's jump in then to number 3. Find the margin of error for a 90% confidence interval. The standard deviation is 50 and n is 25. So I believe we plug those numbers in.
I watched the videos that accompanied the reading in that, and the videos were so much easier to understand than the darn reading. But the issue is that in the video, it's already give you the mean, and I don't have the mean. If I had the mean, then I have the answer already.
Well, I think we plug in 0.9 to the probability output, right? To the top, at the top.
Right, correct.
And then we...
And that should give you the 1.645.
Yeah, 1.645. And then we just do this equation here, which is the little x with the line over it, which is sample mean. And we can do either minus or plus. Plus 1.645. Plug it in there. So let's see. I guess we can both do it and see if we get the same answer.
But what would the value of the x bar be? Because that's the mean.
Oh yeah, that's a good point. So they don't give us the mean. I'm reading.
Yeah.
I'm reading 4 right now, trying to figure it out. Is it 50? 50. So m equals 10.
N should equal 5, doesn't it? Square root of 25.
Sorry, I was doing... Yeah, so you go 1.645?
Yeah, 1.645, yeah.
So I got 16.45 to... And that equal... m equals 16.45.
I guess we don't need the mean. We only need the mean when we need to find the upper and lower. So the answer should be the 16.45.
Oh, really?
Yeah. Yeah, I was looking at it wrong. Because I wrote down the equations in the Excel spreadsheet. And
Oh, yeah.
you got to take that.
It does say find the margin of error. Okay. So it should be 16.45. Is that what answer you got?
Yeah, 16.45. Yeah, once you said that, then I started looking at it closer, and I was going through my formulas, and I found where my error was. I was assuming because I stack my stuff, so I have like in one cell I'll have the mean. Right below that I'll have it labeled 95 applet. To me, that's just my note saying it's either 95 or 90 or 99. But to use the applet to find the z-score, and then I have standard deviation, then square root of n, and then 95 confidence level. And then so I plug all the numbers in, but for some reason I was thinking once I got to 95% confidence level, I needed the mean, but it has nothing to do with the factoring until you need to find the upper and lower.
Sounds good.
So, yeah, so 16.45 is what I got.
Okay, number 4. So the following statements is true. I was just reading about this. Okay. We're going to send him an invite.
Okay, yeah, I just got it too.
Okay.
Hello. Hey, guys.
Hey, what's up, man?
Sorry I'm late. As soon as 10 o'clock rolled around, I had to work for a little bit.
That's all right.
All right.
We're on number 4, so we haven't got too far.
Glad I didn't miss
I'm pretty confident we got 1 and 2 correct, but we'll see at the end.
All right. So I watched the videos for these. So for 90% margin of error, you can put that into the probability applet. You got 0.126. That I guess.
For which number?
Well, no. I'm talking. How did you guys solve for 3?
Oh. Well, you plug in 0.9 to the area.
Okay. Then you get 0.126, right?
And you only select the middle area there.
Okay.
So if you only select the middle area and then you plug in 0.9 at the top, you should get 1.645.
Okay.
And then the formula.
But I say it's like getting the one part where you the reservoir area.
And one a little.
But you're on a diet, that is not a diet. It's ruined it. So I wish I could work good shift, man.
The formula is the square root of n divided by your standard deviation, right?
Or all the turkeys are in there.
So the equation should be whatever you found in the applet for the z-score times divided by the square root 5, which is 5.
of our mean, which was 25, right?
What's that?
It was the square root of 25, right?
Yep, square root of 25 is 5. Yep.
Okay.
So there was this system manager. Anytime I see the guy, it's like he really trying to work out. Outside of the window.
Yeah.
In my area, he started talking, or no, he came in my area.
I'm hearing a lot of background noise.
And he was just looking.
Yeah, it's mine.
Oh,
Yeah,
I
I
couldn't
got my brother-in-law and my wife are talking.
I couldn't tell if I just wasn't hearing you guys right, or
I think
It was
I don't know
muffled.
about you, Dave, but I think Alex is a little bit muffled.
In my muffle, I've got headphones on.
I got mine on. Are mine coming clear? I've always worn headphones every meeting we've had.
You're fine.
Okay.
we're good. I just couldn't tell. So for number 4, for number 3, Alex, we got 16.45.
Okay.
On number 4, I believe it's B.
And how do we know that from the reading? That's what I'm trying to find.
I think it says it. I could be wrong. I think it's under 3.1.
Very beginning, huh? Oh, I see. Yep. Yeah, I'm pretty sure you're right. I see it. Okay.
Yeah.
That would make sense.
All right. We ready for number 5?
I think so.
All right.
Sounds good. Let's see here.
The deep score that we're going to use is 1.6.
Gina wants to construct a 95% confidence interval for GMAT scores. She knows the standard deviation is 113. She collects a sample random sample of size n equals 64 and computes sample mean equals 526. Use this information for the next 6 questions. What is the point estimate for the true GMAT score? Okay, let's see. So I believe the way we do that is we find the margin of error, which we know how to do, and we add that to the margin of error to the sample mean.
So how do we find the margin of error?
Same way we did for question 3.
Okay.
95%.
Type in 95% up top. Which when I type in 95%, I get 1.96.
Yep.
The Z-score.
Yep.
What I use.
That is correct.
So now we do 113 over 8.
Mm-hmm. Right.
And then we multiply that by 1.9. Okay, and then we I don't get if we add or subtract that.
Well, I don't know because it doesn't technically tell. So if we add it, then we're finding the upper, and if we subtract it, we're finding the lower.
Yeah.
It's
So
just asking for a point.
maybe the point estimate for the GMAT score is, oh, that is the mean. That's going to be the 526.
Oh, okay.
That is the true mean that we know of.
Yeah, so I was taking a step ahead. I was doing interval.
Right, which will be the next one, though. What is the margin of error for 95% confidence interval in the true GMAT score?
So for number 5, it's 526.
Yep, it's the mean itself.
Okay.
I really don't like these questions.
526. And then I think margin of error I got 27.685.
That's what I got. I don't know how far we're supposed to round it, but because it doesn't say.
It says at the beginning to round it to 3, so
Oh, true. That's right.
yeah.
All right.
And now lower limit, that made it real easy actually.
So the
Now
lower,
we subtract.
lower limit's just subtracting that 27 from top of their 526, right?
Minus 27.685. So I got 498.315. So what you guys got?
Let me find out here a little bit. Oh, there we go. Yep.
Okay.
Yeah, and then for 8, I got 553.685.
Yep.
153.685. Yep. What would happen if she increased the sample size?
Oh, I just read this. So the sample size would increase with it. If the confidence level increases, so will the sample size. But the next question,
Sure, I think it's no change.
No, I don't. It's not no change. If she increases the sample size, say she.
Yeah, we didn't do anything with the sample size.
No, if she increases the sample size, the equation changes. So it would be. Let's say like if you increase it to. If you increase the sample size to 100.
Oh yeah, it's your square root of change.
Then it would be 113 divided by 10. And then your margin of error would go from 27 to 22.
So because you decreased it, it would decrease, right?
I believe so, because then the interval is going to be smaller. The the more samples you have, the less the margin of error is, which makes 100% sense.
So number 10 would be decrease as well.
Number
Yeah.
10, do not remember. I think that was decrease.
0.99
Yeah, it would decrease.
would
Wouldn't it?
Yeah,
decrease.
because
Is-
with less certainty.
So the z-score would go up,
Right.
which means
Oh, no, it would increase.
it would increase.
Yeah,
Yep, it
because
would
if she
increase.
wanted to be at 99% sure, she'd have to stretch her width out further to cover the base.
Yeah, z-score goes up, so the
Multiplier
multiplies
goes up.
margin of error multiplies to a higher number.
Yeah, so it increases. Apologies.
All right.
So we can go with that 111. So question 11 then, Bright Bulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin error of 50 hours. What is the sample size they need?
Oh. So 95.
75 is that standard deviation.
Let's see. That would be 400 divided by x.
By the square root of x, wouldn't it?
Let's see.
So it should be the z-score multiplied by the standard deviation divided by the margin of error, which before the square root I got a 15 point. Squaring it, I got 15.68. When I squared it, I got 245.862.
We're gonna round to the nearest whole number.
So that would be 246. And it doesn't matter. Like if it's any partial of a number, it doesn't even matter. It does not follow the normal rounding rules. So if you look at the example, when it says if you get the example that it gives for the answer in question 11, it says if you get 101.2, you automatically round it up. Any kind of residual leftover that doesn't make a whole number automatically qualifies as a whole number.
Let me do my math here. Reverse engineer this. Let's see.
So what did you got? 243.36.
For my answer?
Yeah.
No, it has to be a whole number. I got 246.
Okay. Yep.
Let me just take 1.96 times 400. Next. Plus 50. So what did you get for your answer?
246.
46?
Yeah, 246.
246.
I don't know where you saw that you round up, but I'm taking your word for it.
It's so where you enter the answer where it says 246, right above that it says your answer. Then right above that it says what is the sample size they need, and it says round up to the nearest whole number. Example: if you get 101.2, round up to 102.
Okay.
So even though rounding up is totally against rounding rules, you do that for this segment.
Which makes sense. If they're trying to find the meaning of the product, they're going to go one above versus one above.
Right, exactly. They want to make sure that they cover it.
246. Yeah, that's the right answer. I don't know how you got to that, but that is the right. You're right.
You threw it so you have it.
Did you just
I have a formula in, like I said, I watched the videos and they walk you all the way through it, so I labeled all of my formulas so I have it right.
Oh, okay.
So, but all you're doing is just finding, so like I said, in Excel, here, let me see. Let's go to this. Okay. I don't even know if I leave that on. Let's go to this one. All right, can you guys see my Excel?
Yep.
Okay, so with like I said, I just labeled it 95 applet. It can be, you just got to find the right z-score. So this is the z-score for 95%. We have the standard deviation. We have the margin of error. So what I do is I put in the equation of the applet multiplied by the standard deviation divided by the margin of error, which gives me the 1568. And then I got to find that. So I got to find how it squares. So it's literally just it times itself. So is what I put down. And so that's how I came up with the 246. Because we have to round it up.
All right.
Does that make sense?
Kind of. I think you just. I understand the principle behind it. I don't know how you have it all set up like that, but yeah.
All right. So we on number second half of, oh no, going to a 12 here.
Yeah.
So the mean salary of actuaries is 100,000. The standard deviation is 36,730. You are interested to know if the mean salary for women's actuaries is different from the population mean, but are not sure if it is higher or lower. You set up a hypothesis test to level with level of significance 0.05. So you collect a sample, a simple random sample of 36 women's salaries and find that the mean is 111,000.
They're taking us back to the last lesson.
Yeah.
That's okay. What is the lower limit of this 95% confidence level? Okay, we know how to do that, right?
Yeah, I think so. But we just got to make sure we use the right numbers.
Yeah. So we got the standard deviation. We do standard deviation divided by 6. And then we're going to multiply that number by, what was it, 95%?
Yeah, it should be 95 because the A equals 0.05, so it should be the opposite.
So it's going to be times 1.960. 1.960 equals. So I've got 11,998 is going to be the confidence interval, so we're going to minus.
I subtracted it from the 111.
I think that's what you do, yeah.
99,001. 99,001.
So you got 99,001.53.
So it's round to the nearest whole number.
The 99,002.
Yeah, that's what I got.
Okay.
So now
What
we're
is it?
going the other way.
Yeah, I got 122,999.
Only 22,999.
Yeah, 122,999.
9. Okay. That is right. There are 3 requirements that need to be checked when computing a confidence interval for a mean. They are: a simple random sample is drawn from the population, all of the above, right?
That's what I thought too, because it specifically even says in the question there are 3 requirements.
Yeah.
You want me to go ahead and submit?
I can submit. I haven't submitted for a while.
Yeah, go for it, bud.
And 100.
Oh, nice.
Nice. Heck yeah, I'll take that any night.
Got it in one shot, huh? It's not
Heck
bad.
yeah, that's what's up. Heck yeah.
Yep.
Alrighty.
So
Well,
you guys, hold on. You guys got 100%?
I did.
yeah, did you not?
No, I got half credit for 2
Yeah.
questions.
Yeah, but that's all they were worth.
Oh, I see. Well, no, hold on. I'm still missing something then. Let me go through. Maybe I typed in the wrong number.
Which one did you miss?
Oh, 9. I must have hit down or something that selected a different answer for me. It was an increase, wasn't it?
I already got off the page.
Let me see. I got mine back up. So 9. 9 was decrease.
9 was decrease. That's where it's at. Yeah, I must have hit up or something. I had no change selected for some reason.
Okay.
Okay.
No.
Yeah, I'll just retake it. It'll be good.
Okay. Alrighty, guys. So Wednesday.
Yep, Wednesday it is.
Yep, we'll see you then.
So who's submitting this tonight? Like Kelly or?
No, it'll be Nate. He recorded it tonight.
Okay, perfect.
Yep, I've got it.
Alrighty. Thank you, guys.
Hey, no problem. We'll talk to you later.
Bye.